This is pre-calculus 4.6 day 2 notes, and you are going to be applying phase shift to tangent and cotangent. And before we do that, I just want to kind of have you recall the basic structure of graphing tangent and cotangent. And so the period for both is pi. And if there's a change, horizontal stretch or shrink, then to find it, we divide by v. And the key increment's going to be 1/4 of that. And so whatever the key increment is for take tangent. For tangent, you go 2 key increments to the left, and there is an asymptote. This is just for the normal graph of tangent. And then you go 2 key increments to the right, and for tangent, there is another asymptote. And halfway in between, at 0, tangent is 0. And when there's no vertical stretch or shrink, it is at -1 at 1 key increment to the right, and it is at +1 for 1 key increment to the right. And then there's this change in concavity, so kind of like a cubic graph. So stay close to the x-axis for a bit before you pull away, and then it follows the asymptotes, gets closer and closer and closer. And that is your normal graph for tangent. And part of how you should know that it starts at 0 is on the unit circle. At 0, we have the point 1, 0. And the tangent of 0 is y over x, which is 0 over 1, which is 0. So you should be able to figure that out, that at 0, tangent's 0. And then for cotangent graph, you have an asymptote on the y-axis. So you have an asymptote on the y-axis. And you should be able to, again, be able to use the idea of the unit circle to get you started, that the cotangent of 0 is x over y, which is 1 over 0, and you can't divide by 0, so it's undefined, and that's why there's an asymptote there. And then you go 1 key increment to the right, 2 key increments to the right, 3 key increments, and then we're to 4 key increments. And you have another asymptote. Halfway between the asymptotes is where cotangent would be 0. 1 key increment to the right, you are at +1. 3 key increments to the right, you are at -1 for cotangent. And there's your cotangent graph. So tangent increases, cotangent decreases. And that's just your basic footprint for tangent and cotangent. So then let's move on to today's notes. And we've got our 4.6 day 2. And just like we had in sine and cosine, we take out the b, and then we have this x minus c. And c is what you shift to the right or left. So tangent or cotangent. A is not an amplitude, but it is a vertical stretch or shrink. And if it's negative, you have a reflection in the x-axis. So let's just jump right in to this example. In example 1, b is 1. It's a 1x, and so therefore b is just 1. And so the period is pi divided by b, which is pi divided by 1, which is just pi. So there's no change in period on this one. The key increment is 1/4 of that. So the key increment is pi/4. This minus pi/2 means your phase shift is to the right pi/2. And then, as what we did in sine and cosine, for the key increment and the phase shift, you want a common denominator. And that we would want to switch the phase shift to be 2 pi/4 so that they have a common denominator. And that means that we want to grid this out by that smallest common unit, which is pi fourths. It'll make it easy to shift to the right 2 sets of pi fourths. So my key increment will be how I'm going to grid this out. We'll be at pi fourths, and since it's tangent, I'm going to go 2 key increments to the right and 2 key increments to the left. Excuse me. And this is before shifting. So for tangent, there would be an asymptote if there wasn't a phase shift, 2 key increments to the left, 2 key increments to the right. And in between, at 0, tangent would be 0. I'm going to switch that out to an x because it's not my final point. But we also have a vertical stretch. So instead of being at -1, at 1 key increment to the left, it'll be at -2. 1 key increment to the right, it'll be up at +2. So that would be what it would look like if there wasn't a phase shift. But now we need to go right 2 pi fourths. And so 2 pi fourths is going to put an asymptote here. And 2 pi fourths is going to put an asymptote here, because it's going 2 of those key increments to the right. So we get an asymptote on the y-axis. And so that second asymptote would be 4 pi fourths, or at pi. And then each of the points is going to move 2 key increments to the right as well. So that's going to move over here, this one's going to move here, and this one's going to move here. And so for one period, tangent's going to look like this. And then we can continue in the same pattern to add a second period. 5 pi fourths, 6 pi fourths, 7 pi fourths, 8 pi fourths. And that would be where you'd have another asymptote, halfway in between 0 and we're at -2 and +2. So that's graph for 2 periods. And so then we have equations of asymptotes. And they're at x equals 0, x equals pi, and x equals 2 pi. And you have your x-intercepts, and they're at pi halves and 3 pi halves. 6 pi fourths reduces to 3 pi halves. Any questions? All right, so on the next one, I want you to make use of structure and pull out the b, just like we did on sine and cosine. So we take out 3. And when we divide by 3, we actually end up multiplying pi halves by 1/3. So this becomes a pi 6. And it's always a good idea to check that if I remultiply 3 in to those two, do I get back to the 3x plus pi halves? And I do. So the period on this, since b is 3, is pi thirds. And the key increment is 1/4 of that. It's pi twelfths. And then the phase shift is left pi 6. And as in the last example, and sine cosine, you want a common denominator between key increments and phase shift, and that would be twelfths, and the phase shift is 2 pi twelfths. And so take a small common unit to that, which is pi twelfths, and that's what we want to grid it out by. And so for cotangent, you would start, before phase shift, with an asymptote on the y-axis. And then you've got pi twelfths, 2 pi twelfths, 3 pi twelfths, and 4 pi twelfths. And at that fourth key increment, you would have another asymptote, which is the length of the period. It's pi thirds. Halfway in between is your 0. And then you have a vertical stretch by 2. And one key increment in, you are normally at +1, but because of the vertical stretch, you would be at +2. And I'm going to change that out to an x. And 3 key increments in, you would be at your -2. And now you need to apply your phase shift, and it's 2 sets of the pi 12, so we need to go 2 key increments to the left for all of these. And so this asymptote is going to move to here and be here. And this asymptote is going to move 2 to the left and be here. So moving all of these 2 pi twelfths to the left, moves it there. And each of these points are going to go to the left 2. So they'll be in those 3 spots. And so we're to the left 2, to the left 2, and to the left 2. And there we have one footprint of cotangent. And continue the pattern. When you skip over the asymptote on the right, you start at +2, then to 0, then to -2, and the next increment will be another asymptote. So we have a 5 pi twelfths here and a 6 pi twelfths. And so then you have your equations of the asymptotes. X equals a negative pi 6 and x equals pi 6. The distance between those needs to be the distance of the period, the length of the period, and the distance between those is pi thirds. It's 2 pi 6. And then the last one is, let's see, 2 pi, it's pi halves. Silly me. You're at 6 pi 12, so it's at pi halves. And then you have your x-intercepts. And they're at 0 and pi thirds. 4 pi 12ths is pi thirds. The distance between x-intercepts is also the length of the period. All right, and one more here. Again, make use of structure. The -2 is going to reflect this over the x-axis and stretch it. When I pull out 2, that's the same as multiplying pi fourths by 1/2, and I get a minus pi eighths. And so B is 2. So the period is pi divided by 2. And your key increment is 1/4 of your period. And you're going to the right pi eighths. And that is your phase shift. Oh, and that's nice because the key increment and the phase shift already agree. And since this is tangent, I would start by 2 key increments to the left would be an asymptote, and 2 key increments to the right would be an asymptote. Halfway in between there is the 0. But this has been reflected. So while normally we go a key increment to the left down 1, it's been reflected and stretched. You are going to be at +2. And 1 key to the right, you will be at -2 because of that reflection over the x-axis. And then you need to move everything to the right. 1 pi eighths, which is 1 unit here. So you're going to have an asymptote here. This is going to move, and you're going to have an asymptote here. And every point is just going to move 1 box to the right. And so we have an asymptote here. We have an asymptote here. And move each point to the right 1. And there is 1 period. And that pattern just continues. If we go through 2 periods. Oops. Again, try to flatten out as you go through the x-intercept so that you get that feeling of a changing concavity. And as far as values for that, we have a 3 pi eighths, 4 pi eighths, 5 pi, 6 pi, and 7 pi eighths. And so our equations of the asymptotes are x equals -pi eighths, x equals 3 pi eighths, x equals 7 pi eighths, and my x-intercepts are pi eighths and 5 pi eighths. Lengths between the asymptotes should be the length of the period. Lengths between x-intercepts should be the length of the period. And this year, this is assignment number 6, and That's your homework, and 43, 44, 47 talk about needing a graphing calculator, but it's not needed.